Hello and welcome everybody. Today we're going to talk about DevOps patterns and anti-patterns for continuous software updates. Before we will start, let's ask ourselves, why do we need software updates at all? Today there are some software that shouldn't be updated. As you know, BC is a command line calculator and it wasn't updated for 20 years. It wasn't updated for 20 years and we have great reasons for that. The first reason is that the terminal didn't change for 20 years, and the second reason is that the math rule didn't change as well. So in that case, there is nothing to update. But this is obviously an exception, right? Because we would like to get more and more updates as soon as possible, mainly because of two reasons. The first reason is us. We are users and we would like to get more and more features every day. And if you're asking yourself, when would you like to get it? Probably yesterday, or before a month, or a week, or just getting it now, right? We just saw a new release and we would like to get the latest feature as soon as possible. This brings company to update software really quick. Take the Nokia Snake game. Actually, I have a crazy story about it. I had this phone when I was like 6 or 7 years old. I played the game, I loved the game, and I finished the game or something like that, and then I cried a lot to my mom and tell her that I need a new phone or I need a new game or something like that. And she told me, just write a letter for Nokia vendors and maybe they would like to add more levels or features or whatever like that, something like configuration. And I tried, I really tried. I was a young girl that's writing a letter and trying to explain them that I really love the game, but I need more levels or I need more games or something like that. And think about it. Before 20 years, it was a crazy idea. And if I really send this letter, they may offer me to buy a new phone or get more games. And there was no concept of software updates on different areas. Another great example for that is that today I'm getting my medical results in my application, so I can also set up an appointment for a doctor very easily in my application, and I don't need to call anyone to approve my appointment. I can just do that in 2 seconds in my application. The second reason is security. As software became more and more important, the security vulnerabilities became more and more popular. So whenever we have a security breach, we need to identify the breach, fix it, and then deploy the fix as soon as possible, right? Or actually, we need to make sure that all the steps are running as soon as possible, and I'll explain why. So I guess that some of you heard about Equifax story, and in that case, they used the dependencies that contains vulnerability, and it took them 2 months to identify it and that they have a bad agent that gathering information, and they didn't update the dependency. So it took them a while and then they fixed it. But 2 months could be very dangerous. And sometimes it's just not enough to have a security expert in our organization. Of course, it's very useful and it will tell us to fix some stuff and update some software. But sometimes we need to also think about the dependencies, and it's super critical, especially today when we have security threats that by definition they are 0-day. So in that case we can't prevent them, and there is no way for us to learn the tactics and be protected in that case. So it means that one day it will happen, but we will have to react as soon as possible. So a little bit about myself. My name is Batel Zohar and I'm part of the developer advocate team in JFrog. Before that, I was an embedded developer, a web developer, and part of the support team in JFrog. When I was a support engineer in JFrog, I've learned a lot and saw some interesting cases from some customers, so I'll try to share some of them today. I also have an amazing doggy named Benjo, and before 2 months we just adopted another beautiful girl named Sol. So I would really would love to keep in touch with you guys. Feel free to reach out to me on Twitter, email, Facebook, LinkedIn, or whatever. And please do not hesitate to reach out for anything. I'm pretty available and I really love to help. So let's start how we can update faster. I hope that everyone already understands that we have to update as soon as possible. Let's start with an example from Java. in 2017, Mark Reynolds, head of Java platform, announced a faster release cycle, which is really cool. Java usually released new version whenever they had enough scope and enough features. So in 2017, they decided to change it and release whenever is needed. Since then, we released a lot of versions like Java 9, 10, 11, 12, 13, 14, 15, and even 16. So now we have 8 new versions. Since we don't have 2021 results, we will take a bit and we will talk a bit about 2020. So now when we look at the adaptation of this version, it will look like that. We ask some developers which version of Java do you regularly use, and 75% of the people said that they are using Java 8, which is crazy. What about all the versions that we just saw that they released very easily? So why do we don't want to take those updates, right, and upgrade to other versions? To understand this process, we need to look at the process of how we're going to update everything in our organization. So first, an update is available, right? We got a new update and we need to understand if we want or not. Sometimes we just don't want to need a small feature and it's not part of our organization needs, so we just don't need to upgrade, and that's totally fine. Now let's say that we have something that it's really interesting our organization, and let's think a bit about the risk. If there is no risk, that's awesome. We can just easily update to the latest version or the next version and everyone will be just fine. And of course you can always play with the latest version on your local computer, and if you will break something, nothing crazy will happen, but when we are talking about production system, it's totally different story. So the risks are higher than your local machine and it's totally a different story. So let's say that we have some risk, but do we trust this update? You know, how many backups we need to make sure that we can just easily roll back, or how we can make sure that this is just fine and we can easily upgrade. So if we trust it and we believe that we will be just fine, let's update. But if not, we'll just stuck, and we need to better understand why we do not trust those vendors. So we sometimes said that probably the quality sucks, right? They don't know to do a QA, but in 2021 we should know how to test our software. Today the software are so complicated that it's really hard to test, because we are not able to create all the production environment because of the complexity of the amount of data. It could be very, very interesting. So the problem is not the code, it's the data that's getting bigger and bigger every day. So I guess that some of you already heard about petabyte, exabyte and zettabytes, which is huge numbers. It's like a lot of data and that much data. So staging server is never exactly the same as the production server. And this is why a lot of vendors releasing versions that are not tested enough, and they are not lazy. It's really very hard to test it. So this is why we stopped to trust the vendors, and this is where we have the problem, because we don't trust the vendors and we have to you know, just check it again and verify that we can take a long time. So let's say that we are not trusting it, and then we're starting with verification and some testing to make sure that we can really apply it on our production. So sometimes it's not really worth it. The verification take more than the next release cycle, and then we're getting to a cycle of testing again. So a lot of vendors bring in to the vendors to put more food on the table, so they will try to add more and more features. So we want those features and we will update. So in that case, we have the features that we want against the acceptance of the test cost. And then we'll have another cycle. So let's talk a bit about that. The users want updates, so the vendors will add more features to each and every release. And now the updates are even more dangerous, right? It's crazy. We have tons of features that we need to test before we are applying it on production. So it looks like small chit-chat, you know, we'll click maybe up, up, down, right, left, and maybe it will work. So, for example, let's talk a bit about update of our browser, right? We have our browser. How many people know the version of their browser? And how many people know the version of the Twitter in our browser? And I guess that some of you may have, automated updates on your smartphone. So, but your smartphone OS and they control it. So, because sometimes you heard that it's unstable, this is going back, and the risk factor and the idea that we don't trust vendors. Sometimes we just heard that this version is not stable, so we won't update and so on. But sometimes we just said, what can possibly go wrong, right? So I guess that not too much people really updating their router, and actually we have a crazy story about it that I heard from a colleague. He was on a flight, and then his wife called him and told him that the lights are down or something like that. She's trying to talk with Alexa, nothing happened, so she clicked on the switch and really turned on the lights, and she didn't have Wi-Fi at her house, and that's actually happened after an upgrade of their router or Google router or something like that. So it's really nice that they're sending a mail whenever we don't have Wi-Fi, so we need to, just use his phone to read the email and reconfigure some stuff. And yes, it's oops, sorry, we went to update, we update the router, and you just need to reconfigure it by yourself. And the problem is, of course, that we need email to get this email, right? We need some internet access to get this email. So obviously with router it's not so bad. We can go back and reconnect it, but think about a remote production which is not really accessible, like updating solar panels on the desert or something crazy like that. What will happen in that case? And in that case we need to think about local rollbacks. So we want to update when catastrophically and we have issues and AirPatch can't reach to the device, so we need to have a previous version saved on the device prior to update to make sure that we can easily roll back. So this is a screenshot from Windows 98, which is pretty old, and there is the message here. I know that most of you hate this message and just wanted to continue, but this is pretty smart. In this message you can ask kind of a local rollback that even run automatically, and after 30 seconds it just revert back automatically, which is pretty smart. Think about it, that we have some issues with the resolution, and I believe that most of you tried to change resolution. It was huge and super small and stuff that you didn't read the monitor settings. So it's pretty smart, this rollback. I claim that I could be, everywhere. It could be on your local network, on your device, and it could happen anytime, at any service. So self-updating course, it's pretty fun. Think about it, that you are driving and we have an update to our car. So here is an example of Jaguar. Jaguar I-Pace, and it was on June 2019. They realized that they have a bug in their brakes, but the thing is that there is no way that they can update their car, so they have to recall all of them just to update the software on that service. So it's nice, you have a smart car, but you can't really upgrade the necessary software. So physical updates are extremely costly, right? The problem that we have to recall all the cars, but it's extremely costly, and you can force them to an upgrade, right? How you can force them to call for the garage. So the solution is implement over-the-air software updates that preferably continuous updates. Let's talk a bit about continuous updates. Continuous updates, it's really cool and it's really fun, but what better than that? I believe that continuous over-air updates. So Tesla is amazing. I guess that some of you heard about Tesla, but one day they had a bug, and it was on the autopilot, and it's called phantom braking. Phantom braking is when the Tesla drive on the middle of the road and it's clear river and no obstacles, and Tesla autopilot will slam on the brakes, and it's pretty annoying, You're just driving and then slamming the brakes again and again with no really reason. You don't need reason. So people complain that there is a rumor that the next update will fix it, and then people are waiting, then nothing happened, and it took time to hit the car. And then it turns out that the issue was released with a chess game. And of course, also a minor improvement that fixed the phantom braking. As you can see here, the release contains minor improvements, very minor, that made people very angry. And that's totally understandable. Phantom braking should be prioritized over chess game. But same happened for people that really wanted to play chess, right? They really want to play chess while they are charging their car or something. They never use the autopilot and they just want the chess game. They don't want the small improvement that's really related to the phantom braking. So they waited for a long time for this really phantom braking release, even that they're not really using it. So in that case, we need to think about continuous updates. The problem is that we have a batch of updates that are really important features that waiting for non-important features. So the solution is to implement continuous update, right? We would like to create very small updates to make sure that we can easily upgrade to those small updates. And let's talk a bit about companies that are not related to IoT, like KNIGHT Capital. It's a Wall Street company that specializes in electronic trades and wanted to update their software, and it's happened after a year that they work very hard on the system. In that case, they lose tons of money, and let's explain a bit more why. So they decided they are keeping the old APIs, which is fine, and they just forgot to update one of the 8 servers, right? 7 servers was updated, one of them is not, and then new clients sent requests to machines that contains the old code. They noticed that it's doing, some stuff that's not really related. If people want to buy it, it just sells some stuff and do some weird stuff and act very weird. So engineers undeployed working code from update server that increasing the load and not updated server. And they didn't have monitoring, no alerting, no debugging, and then it cost $440 million after 40 minutes. They found the issue after 40 minutes and lose $440 million, which is huge. So in that case, I think we need to think about automated deployment. So people are really stuck in repetitive tasks. We need to make sure that we can automate everything. We just not good in those stuff. To do the same thing again and again could make a lot of problems. So if we need to automate it, we also need frequent updates, right? To make sure that we don't have deployment of, stress or leading to errors. We can be on a huge pressure whenever we have a big upgrade for production. So the solution here is to update frequently, to develop skills and habit to make sure that we know how to handle in case that we have errors on production or just issues during the upgrade. So yes, practice makes us perfect. Now let's talk a bit about state awareness. The problem is that the target state can be affected, the update process and the behavior of the system after the upgrade, right? It may be a good decision to use the old API, but it may also always remember that you have a side effect. And you may have, users that using the old version, and reverting may require reverting of the state. So again, consider target state when updating, and reverter may require to reverting the state. So here is another relevant example, Cloudflare. I guess that most of you heard about it. Again, they took down 30 minutes of the internet in the summer last year, before 2 years, sorry. And let's see what happened there. Cloudflare battle internet attack by developing new routing rules, and they developing single misconfigured rules, which is fine. So the deployment of the single misconfiguration rule and included regex that spikes the CPU to 100, and then it's affected all the regions because they have disaster recovery that's coming from one server to another. It spiked also, and the internet was down for 30 minutes. In that case, we need to think about progressive delivery. The program is releasing a bug that affected all the users, and in that case, we need to release a small number of users first, effectively reducing the blast radius, and observe if the problem occurs, stop the release, revert or update the affected user. So in that case, we don't want to hear about the issue on Twitter, Stack Overflow or stuff like that. we want to make sure that we're testing it like a feature flag or something like that. So actually I believe that our parents also told us about that before a long time. In any fabric or treatment, you will have this message and it will tell you to test it on a small piece or in a small batch. So you decided if you want to process, and if there is any damage occur, it's just a small damage, it won't affect the whole production environment. So let's talk a bit about observability. Some problems are hard to trace, of course. We are relying on user feedback only, and the solution is to implement tracing, monitoring, and logging. Again, we don't want to hear about very bad feedback on Twitter from our customers. Now let's talk a bit about rollbacks. The problem is that fixes might take time and users suffer in a meanwhile, so we need to make sure that we can easily provide them a rollback and they can just revert back to the old version and nothing happened. But implement rollbacks is the ability to deploy a previous version without a delay. But what will happen in case that we can't really provide a rollback? Whenever we are talking about, let's say, a mobile developer, so Apple Store and Google Play, you can't really create a rollback. You need to create a new version, and then you will be able to upgrade to the new version that you created, which is actually a rollback. So in case that you find a bug, you have to create a new version and you wait for a review, and it can take some time. But you can also use feature flag, and it will allow you the ability to change it in REST API. So you embed two versions of the feature in the app itself, and you trigger them with API calls so you can easily control it and don't really need to wait all the time for the review. Now let's get back to Cloudflare for a second. So they just take down a chunk of the internet again before a year. You see, in July 2020, something very similar happened again. The funny part in that story that it was very similar. They do a maintenance on Chicago server and wanted to reroute the network from Chicago to Atlanta. And again, they use a regular expression that went wrong, and they managed to route all the traffic through Atlanta. That crashed some stuff in the middle, they crashed another server, and they took to the load chain of reaction boom effect, and region Earth was affected again. So basically they had a change of reaction and everything was crashed. We had a huge crash, we didn't have internet or something, and let's talk a bit about automated deployment. So the problem is, again, people really sucks on repetitive tasks. And we need to automate everything, right? We already said that. So let's try to summarize. Continuous update should be frequent, should be automatic, should be tested, progressively delivered, and state aware, and of course observability, as I said. And if possible, local rollbacks are super important too. Then we build this trust with our vendors, so we have an update, we really want that, we can take the risk, or we just don't have risk, right? Because we are just believe in our vendors and we can trust them. So our goal is transition from bulk to rare software updates, extremely tiny and extremely frequent software updates. So tiny and so frequent that they provide an illusion of software following from development to the update target. We call it the liquid software vision. So we have a great book that our CTOs write about it, Freight, Simon and Yoav Landman, and also Baruch Dabrowski. They talk a lot about liquid software, how we should update, why we should update, and how we can make sure that we can trust our vendors. You may want to log into our website to read more about it. But before we're ending, let's talk a bit about corner cases. Of course, we don't want to update the medical equipment during the surgery. Probably not the best idea, right? During the surgery, it could be pretty dangerous, but they are much less frequent, right? How many times you heard about medical equipment that really upgraded? So now let's talk a bit about plans. Airbus have a memory leak and they have to be restarted every 149 hours, which sounds like crazy, right? Sounds really weird and sounds very dangerous. But it's happened to other companies as well. Boeing 787 must be turned off and every 51 days. And it's happening. And actually they had a register leak and it have to be restarted every 51 days, which is fine. But let's imagine that you have a flying to California or Japan and there is no landing site. So in that case, the cockpit asks the pilot if he restarted the plane this morning, and then he will hear, you hear just a oopsie or something like that. What will happen next? And we're talking about April 2020, right? It's not so old. And it's happened before, Boeing 777 took some developers to make sure that the problem will fix, and that's take, from a great book that's called Project to Products. I really recommend about this book. You may want to hear more about it and about software updates. So thank you again. Thank you very, very much. My name is Batel Zohar again, and you can find more information about the Liquid software on our website. And thanks again for having me today. Have a great day. Bye-bye.